All right, well, welcome back. We're going to be finishing up and talking more about domain and how to find domain. So, key topic is how to find domain. We're going to talk about how to find this numerically, or not numerically, algebraically. And also how to do it graphically. Okay, one more is graphically. All right, so here we go. When we talked about this before in a previous tutorial, is that we had a equation or a function. Let's go f of x. And we said that we always considered f of x, so whenever we would see any of them, like x cubed plus x squared plus 1, we would look at the function and we would consider, okay, what is the domain? Well, we start with the implied domain. Implied domain is what you think all functions, what can you plug in? Well, the implied domain is always going to be all real numbers. All right, so this means all reals. You may also see this using interval notation, or you can see it in other calculus books or other books. You write it like this. All right, another way you could write it as negative infinity. Right here, that is the domain, meaning implying all reals. Now this is a cubic function, and I can plug anything into it. There is nothing that leads me to believe that I cannot. Well, there are some instances where we can have other ones. So for example, if we had h of x, a different function, and we had x squared minus 3x over x squared minus 5x. Well, in this function, this is what we call a rational function. If we start with the implied domain of all reals, well, we realize that it has a denominator. All right? And in the denominator, we realize that for certain values, we cannot divide by 0, okay? No dividing by 0. That is no. Okay? There. You can't divide by 0. There. Hopefully you remember that. So whenever we see a rational function or a function that has a denominator, we know that it has a restricted domain. Okay? So this is going to have a restricted domain. Restricted domain. To find this restricted domain, we're going to find out when the denominator equals 0, because we can say it's going to be all real numbers except x equaling, well, whatever the denominator is 0. So to help us figure this out, we're going to take the denominator, and this is what we can do. You can look at it and just write on the side, all right, denominator, and we're going to find out when that equals 0. And so what we have right here, I realize that I can factor this, so now we're going to do some algebra. If I turn to x, we have x minus 5. That equals 0, and we have x equaling 0, and we also realize it's going to be 5. So those are two values. When I substitute them in, all right, plug them into the input, and plug them into each one of these values, this x and this x, each placeholder, I realize that I will get 0 in the denominator. So because I get 0 in the denominator, I would say this is all real except x equaling 0 and 5. And that is its domain. Okay, so whenever we see the denominator, find the zeros, then that's what it cannot be. Another way you can write this is x can equal 0 and 5. All right, another way you could write this in being all values from negative infinity to 0. We do a union symbol, all right, 0 to 5, another union symbol, and then 5 to infinity. All right. Most of the time, I think the easiest is just to write that. But you see it in all different ways, depending on the books you have. Okay? Now, another one that we see a lot of, okay, is the square roots. Okay? So if I had, we'll call it s of x, and we have the square root of 4 minus x. It's a simple one. But when we have this, we realize that we have a square root, or an even root. An even root, okay, we know that with any even root, we cannot take an even root of a negative value. So all the values in there have to be greater than or equal to 0. Okay, so any even root, so whatever it be like a 4th root, or a 6th root, or whatnot, okay, all of these domains of all these functions are also restricted. When we have them right here, what we notice is that with each one of these is that their domain, okay, is going to be, well, all x values, in this case, greater than or equal to 0. That's the domain. Or another way of writing this would be, so with 0, we have a bracket. Bracket means equal to in interval form. All right, bracket, you see that, means equal to. The comma says where we're going to infinity, okay, and that's our domain. So x, and then we usually have that, x, all right, the domain, whatever independent variable is, can go from 0 to infinity, okay, or you can run like this. Either one, they mean all the same thing, okay. So in this, we use that term knowing that, well, this input, the inside here, always has to be greater than or equal to 0. Well, that means that this right here also has to be greater than or equal to 0. So to find the domain of this function s, we're going to actually take and create an inequality expression. We're going to take the inside, okay, and we're going to make an inequality, knowing that 4 minus x has to be greater than or equal to 0. When we do this, what happens is now we solve for x. Okay? From here, we're going to subtract 4 to this side. All right, we're going to divide by -1, divide by -1, divide by -1. When we do that, you have to remember your properties of inequalities. We have to switch the signs, and now we have 4. And that right there, so any x value less than or equal to 4, that's the domain of that function. You can test it out by plugging in 4, we get 0. Plug in a plug in a 3, because that's less than 4, we get 1. So it works out, but that's our domain. Okay? So whenever you have inequalities, all right, you always take the inequality, all right, and solve it, and that will help you get your domain. Okay? With that, I hope that helps you out. We're going to go into the next tutorial and find out more about how to find them graphically as well.